Okay. Factor theorem. What? I haven't even done anything yet and I'm already in trouble. Okay, factor theorem. This was a little bit, I kind of went over this a little bit last week. Super easy. To tell if a binomial is a factor of a particular polynomial, you have to have a remainder of 0. Super easy. So to figure out if this binomial is a factor of this polynomial, all we're going to do is do the remainder theorem from Thursday of last week. Easy peasy. So just to remind ourselves, we solve out the x. So we're going to solve out this x so that x is equal to a positive 1. And then we are going to substitute it in to the polynomial. So is it a factor? So if the remainder is 0, it is a factor. Only when it's 0. If there's something left over, like if you have a remainder of 327, it doesn't divide into it evenly, right? That's the purpose of a remainder, is it doesn't go into it evenly. So if it has a remainder of 0, that means it divides into it nicely. There's no leftovers. So this is, yes, it is a factor. Okay, you do the other one. Okay, can you handle that? You're going to make a life choice. No? Oh dear. Oh dear. I need a pen of some kind. Ooh, wonder how pink will show up. Oh, I don't think this is going to show up well. What'd you get for an answer? Is it a factor or isn't it a factor? Can I show you? So just with the negative numbers, it's a little it's not as straightforward because the negative 1 cubed is going to be a negative 1, and that's something that wouldn't happen with a squared or an even exponent. Yes. Yeah. Okay. Yeah, let's keep going. Okay. See, now all of a sudden we're probably going to grab our calculators because ones are super nice because we can just deal with them. And some people are super talented where they can just see it in the equation. You guys don't have to write down the step, but I think that like on an exam or on a test, we have those math fatigue, and it does help to write it down. It doesn't take a ton of time. You do not have to if you don't want to, but I'm just saying it does help. Okay, right away, even if I don't do any of the adding there, is that 0? No. Right? So we've got a negative 52 plus 6. So it's not 0. So even you don't have to get me the remainder unless the question's asking what is the remainder. The purpose of this is to decide if it's a factor or not. And this one is not a factor. So I didn't even bother to solve that, which seems a little sad, but maybe I should. So again, like it just can be a cursory glance at it unless the question's specifically asking what is the remainder. Okay? Is it negative 48? Yes. I thought it was 52 here. Oh, it's 54. 54. That would be my problem. Silly goose. I know. Oh, sorry. So is that 0? Okay, so right there, ladies and gentlemen, you have fully factored this. You got the 3 factors. This is going to be important because I'm going to give you a question that says fully factor this polynomial.
Without your calculator.
Without your calculator. Because that's who I am as a person. You guys know that.
Wait, so how would you find these factors?
Ah, we're going to go into that. That's like the next step. I'll ruin the fun. It is they're the factors of 3. Like all of your constant. So plus minus 1, plus minus 3. Right? I don't know what you're saying, but sure. Okay. I'm with you. Okay. 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 This is a lot of writing. Really not terrible. This is going to be the question I'm going to ask. I'm going to say fully factor that. And that's all I'm going to give you. I'm not even going to give you that. I'm going to say factor that. That's going to be a question on your test and on your exam. FYI. Not this particular one, but this style. So I'm going to say fully factor that, and I'm going to walk away. Okay, so you need to break it down into all the factors. Like, so on our last page, sorry, flipping back to the last page, we knew that x minus 1 was a factor, we knew that x plus 1 was a factor, and we knew that x minus 3 was a factor. If we times all those together, we get back to the original. Okay, so that's what we're going to do. Okay. All right, so now what you're going to do is you're going to use synthetic division, you're going to use your remainder theorem, and you're going to use a little bit of mathingness to it. Okay, so this question asks, let me put that back in there. This question asks whether x plus 2 is a factor of that. So the easiest way to do it is to use the remainder theorem. And that's shown here, remainder theorem is here. Nice thing about remainder theorem is I don't have to have everything represented, every exponent represented. I can just plunk it in. Does it equal 0? Yes, it's a factor. There we go. So once you know it's a factor, you can go ahead and synthetically divide. And then what's left over is, there's my remainder, there's my constant, there's my x squared. And I think we did this the other day, didn't we? Well, but just we fully factored it. So there's the one we found using remainder theorem. There's the quotient that we found using the synthetic division. And we can't go any further than that because this one doesn't factor. So this would be fully factored.
So where did the x plus 2 come from? How would we find
Okay, so that's where okay, you guys are like, you are deep into this. You're ready to go. I love it. Okay, so when you're going to factor this completely, how did we figure this out? Look at your constant. Look at your constant, and that's where you're going to start. So you're going to bust your constant apart into factors. Okay, all right, so, but you guys are thinking on a small scale here. We got 1 and 6, but we also have -1 and -6. And then we have 2 and 3, and we also have -2, -3.
But just from looking, would you not be able to tell that -1 and -6 don't work?
How? No.
Because it doesn't fit in the line.
But look, now you're right. Like if it was just an x squared, that's what we've been kind of trained to do. But now we've got an x cubed, right? So now pretty much anything's fair game. I would always encourage you to start with ones and -1s because those are nice to substitute, right? Like work smarter, not harder here, but sometimes. So you can see with 6, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 possible constants to check in there. Does that make sense to everybody? So what if the constant was 107? Well, that's a prime number, so it's either 1 or 107, so that works. But like what if it was 24? Like these numbers get bigger. They get bigger faster. So this is where we're going to do. So the first thing we're going to do, this will be your question. Factor it completely. That's what I'm going to put on it, and you guys are going to have to do it. So the first thing I'm going to do my factor pairs, and now I'm going to use the remainder theorem. So I'm just going to start with +1. So if I have f of +1, that's going to be 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6. And ladies and gentlemen, I am showing you all my steps so that we just have full and complete. There will be some of you who can look at it, do it in your head, and say yes or no. And what do we say about this one? It's a yes! Yay! Okay, but let's work backwards. I said f of 1. So what's my factor? X minus 1. Right. Nope, we found one. We're good. Nope, we're good.
Well, what if it's like a
Okay, just
good power 4?
okay, but we're gonna go to our synthetic division next, and we're gonna get the quotient. We just need 1 to start our synthetic division. You just need 1 to start our synthetic division. Okay, synthetically divide, please and thank you. I'm going to synthetically divide, you synthetically divide, it's going to be a good time. I think that was 3.2? Was it 3.1? So what do we need? Don't forget we need every exponent represented. I think it's already represented there. Are you guys ready? Can I show you what I got? Or am I going too fast? Okay. Okay, not yet, because we're not done. We need to fully factor. So this one's, so guys, if you don't get that 0 there, and you've got a 0 here, something has gone wrong. Like you've calculated that the remainder is 0. This also calculates that the remainder is 0. If this isn't a 0, we got a problem. And so this is my quotient from dividing x minus 1 into the polynomial. Can we factor this? And so this is your grade 10. That was terrible, learning how to factor. So the nice thing about it is you don't have to go back to synthetic division because you guys can just, you know how to factor this. But what factor am I missing? The x minus 1 has to be in this. So we would say that x minus 1 times x minus 3 times x plus 2 is factored fully. Do not make me chase your math around the page because I'm going to get angry about that.
So if you don't get that,
Did you just tell me too bad, Nicole? You would never do that, right? And so, like, let's say this was a cubed, then you would do this all over again.
Oh, you'd have to go through that, but you'd have to use that constant.
But you'd have to use that constant, yes. So you just keep doing it until you get it down to something that you can factor or not factor. Okay. Does it matter what order these go in, ladies and gentlemen? No, because they're all multiplied.
Does it make you feel bad that John's going to do the cubic side cubic functions in his head?
Okay. Go. Go. Just go. No. No. Just go. Oh, look, Cameron finally showed up. I know she did. I know. And the knee? We not talking about it? Is it torn? Stretched? Oh. So currently it's in limbo. Okay. That's okay. Hey, it's 3. So how many factors do you have to check? You have a possibility of 4, right? But where are you going to start? Okay.
Yeah, -4 is 1, so don't do it, guys.
What everything else, what everyone else thinks, that's for me. Yes.
Well, I'm going to try negative 1.
So what is that? Okay.
I'd much rather try -1 than 3. Oh dear.
Negative numbers.
Does that mean it's 1?
People louder
X
now.
equals 1? Or
No. X equals -1.
X plus 1?
X plus 1.
What did I do to for order?
Oh, why is it,
Okay.
squared?
Okay, so that's what I got for, I started at 1 because that's my easiest one to do. So if I put -1 in here, that means x is equal to -1. So if I work backwards and put it as a factor, it's going to be x plus 1, right? Just keep that in mind. Okay, so now with that information, you're going to synthetically divide. Did anybody try any 3s? Anybody try any 3s? No? Okay.
I did it in my head.
It's always the solved one, Nicole. But did you fully factor? Did you fully factor?
Yeah, I did fully factor.
You did fully factor?
Yes.
Okay.
Oh, this is
Can I show you? Perfect. So not super hard. Basil, what are you on your? You're sending an email to me?
No, to you, man.
Oh, to U of M.
I'm done.
You're good? Know what you're doing?
Yeah.
Okay, so those were all cubes, right? Those were all cubes. So now we're going to try a 4.
Wait, how's it?
What am I waiting on?
Does that mean we have 4 factors?
Yes. Yeah. You're going to have to do this twice. So let me recommend to you that you get a scrap piece of paper out to do your remainder theorem on, or write really, really small. Because you're going to have to do this twice. And it's 24. It's negative 24, folks. Just one. Remember, you always just need one that works in the remainder theorem. Okay.
The factors too.
Because your quotient at the end, like here, is going to end up with a cube in it. And so then we're going to have to do this whole process again, but on the new quotient. Is it 2? Rumor has it on the street that a good factor is x minus 2, Smarth. Is that correct? X minus 2? So I can't stress this enough. Please remember that when you're doing your synthetic division, all exponents need to be represented. And we've been pretty consistent with having them all represented. So I think we might end up being a little bit... Oh, I didn't even do the first part. Okay.
Samara said so.
I don't really like, oh, you're rooting for nothing again. Just dying. How would you make passive-aggressive email sound not passive-aggressive?
That's a tougher. So what are you looking for? You're looking for information, right?
Yeah.
So what information are you looking for?
Like December.
Oh.
I would tell myself, I'm sorry, like...
Okay, so I think you just, hi kind sir, you know,
Exclamation point to see my
yeah,
Oh, yeah.
true, yes, good day kind person, you know, something about, I am very much anticipating a response from U of M. I applied in December, and I'm waited bated breath for my notification on whether, don't say that I'm accepted, like on the status of my application.
Yeah, okay.
Okay? And then you go in with something of, I applied in December. I'm just wondering what the timeline will be before I receive a status notification. If you could please get back to me at your earliest convenience, that would be greatly appreciated. Hugs and kisses. XOXO. Mwah. Yes, they do tell you. You get a letter saying, yeah. Yeah. Don't forget the XOXO. It's really going to solidify your place at university.
Now we're trying to take another.
Okay. Okay. Look, I'm writing letters.
Now you gotta sub another number in this?
Okay, so this is the problem, is that right here, we're left with x cubed minus 3x squared minus 4x plus 12. So we need to keep going with this, and so you start the process again. So we know that this one's a factor. That's good, but we need to break this one down now. So now we're looking for 12. Does 1 work? Minus 2 works again? Okay. Okay, next. There we go. So if that's the case, then we are, I like when you guys do my math for me, that's my favorite. 2 goes on the outside, but now it's the quotient of this one, right? So I'm going to switch colors just so I don't screw it up. So 1, -3, -4, and +12.
Oh, so you don't have to like do the remainder here?
No, we did. Pavlo did it and Samarth did it, and they found that 2 worked again. Again. Guys, there's different factors, so there'll be times where Samarth gets 2 that works, and you'll get a 1 that works too, right? Like, so there'll be times where we do it a little bit differently than the person sitting next to us because there are multiple factors. There's 4 factors of this one, right? So there's 4 different ways we can start it. So if somebody's doing it differently than you, then that's okay. But the key thing here is if you don't get a remainder of 0, then we have a problem. Okay, can we factor that? So synthetic division is great when it's difficult, but if you can factor it, keep going, like do the factoring. If factoring is not your jam, then you're going to have to go ahead with more synthetic division. Okay, so this one is from up here, like that one's from up there, and the second one is the second one. Now you're going to see this written like this. So don't be alarmed if you see it written like that. Obviously, it just means the same things.
Will you take either?
Yeah, I'll take either. X-intercepts, let's talk about them. Because I'm going to ask you to graph these.
Graph?
Yep, when it's in factored form. So we have +3, -2, +2 for intercepts. So let's talk about the end behavior of this graph. Okay, let's go. So let's look at this. It's an even function with a positive leading coefficient. So if it's even, I'm thinking parabola. Yeah, you're right. So it's up, up. It's 1 and 2. It's not a parabola, but what do I know the most is parabolas. The highest exponent. Yeah. So if I were to graph this, I know a couple of things about it. I know that it's an even function, positive, so it has end behavior in quadrants 1 and quadrants 2, and I have x-intercepts at 2, -2, and +3. So there you go. You guys can start to graph polynomials. There's some other things that we have to talk about, but that's the general gist of it. One more question. One more question. A form that's used to make large rectangular blocks of ice cream comes in different dimensions such that the volume in cubic centimeters of each block can be modeled by that, where x is in centimeters. Determine the possible dimensions in terms of x that result in this volume. So what are you going to do? We did this one before. You're going to factor it. Find the factors, folks. Well, and it should be a negative number because when you solve it out, hopefully we're not in negative dimension. No, you do it. We'll wait on you. So what are my factors of 12? 1 and 12. 2 and 6. Then the negative sets of those 3 and 4. Oh, I forgot about that one.
Somebody do the 1 and I'll do 2.
So if I put negative 1s in here, so it doesn't work?
I'm doing -2 right now.
Okay. What? Yeah.
-2? Yeah. It works? Okay. Thanks.
Okay. So if -2 works, so if x equals -2, my factor is going to be x plus 2, right?
Yeah.
So I'm going to continually write that down so that you remember that if -2 works, it's the opposite in the factored form. So with that information, I'm going to synthetically divide.
No, that's too much. That's fine. Yeah, that's what happens if you create an application in person. No, not at all. It's not like you
Can we factor that? So what are the factors?
X plus 2 squared and x
What absurd numbers for what? The remainder theorem or in the division?
Guy, that's not like doing this email right now. Like, I would appreciate if you could get back to me.
See? Did you do the XOXO? Hugs and kisses?
I knew you should.
If you don't get an answer next, just lead with the hugs and kisses, and maybe you're like, I apologize for not including these sooner. I understand you're very busy, and this is a busy time for the university. Salutations, XOXO. We're done. So now you can fully